All right. So for f of x equal to x to the x, we want the fifth derivative and also the 101st derivative. Question? For these questions, there's really no other way than just to try it. Just differentiate once, twice. So what's the saying? A journey of 1,000 miles begins with one step. Is that the saying? Something like that, right? 100 miles. I don't know. So you differentiate once. And when you differentiate this, you have to use the product rule. It's a product. So it's get that. Now, to give you a tip, when you have to do second, third, fourth derivative, before you differentiate again, please simplify. That's why you need to know how to simplify. So for example, here we have two terms, but they both have e to the x as a common term, a common factor. So we should factor that and write down 1 plus x times e to the x. Right? If I factor the e to the x, this is 1 times e to the x, that's x times e to the x. So if I take the e to the x out, what's left inside the parenthesis is 1 plus x, right? Now let's differentiate twice. F double prime of x is simply, you take the first derivative and differentiate one more time. And 1 plus x prime e to the x, 1 plus x e to the x prime. 1 plus x differentiates 2, 1, and e to the x, that, and you get 2 plus x if you factor e to the x. That's because this is 1 times e to the x, 1 plus x e to the x, and so you have 1 plus x inside the parenthesis, but that's same as 2 plus x, right? Okay, so, I mean, some people might see the second one and already are ready to draw some conclusions here, but if you're not convinced, we can do just one more, and that should be enough for you to figure out what's going on. So we take this, differentiate one more time, which is 2 plus x prime e to the x plus 2 plus x e to the x prime, and that's just 1, so e to the x plus 2 plus x e to the x, which is 3 plus x this time. Okay, so it turns out to be rather simple, right? So from here, what do you think the fifth derivative should be?
1 plus x.
So 1 differentiated once, you get 1. 2 derivatives, you get 2. 3 derivatives, you get 3. So the obvious answer is fifth derivative is 5 plus x e to the x, and also the 101st derivative is 101. That's the easy. Now let's try the second one. Second one has e to the 2x in there. The second one has g of x equals e to the 2x. And again, the question is to find the fifth and 101st derivative. Same method. Just differentiate once, twice, third time. You see a pattern, and then just use the pattern to figure out what the general derivative is. G prime of x is 2e to the 2x. G double prime of x equals to 4e to the 2x, just by the chain rule, right? So maybe it's helpful to remember these rules as a separate rule. Although these are really chain rule at work, right? But these are really chain rule at work because AX is the nested function, so you differentiate this as outside and then you pull the AX outside and differentiate. Derivative of AX gives you A, that's why you see an A here. But with lots of practice, these will just be natural. You'll just see them as just regular formulas that you know. Okay, so what do you see? We see that every time you differentiate, what's happening?
It's 2 to the power of that.
Every time you differentiate, you get to multiply by 2, right? So this is like 2 to the first power e to 2x. It's to the second power e to 2x, to the third power e to 2x, and therefore we see that the pattern is the fifth derivative is 2 to the fifth power e to 2x, or 32 times e to 2x, and the 101st derivative is 2 to the 101 e to 2x. And do not attempt to write down 2 to the 101 as an explicit number. That would be crazy. Okay. It's a 30-digit number that starts with 2. It's a 31-digit number. 31-digit number that starts with 2. Okay. Third question was C, h of x equals the sine of x. Let's differentiate once. Now that's positive cosine. H double prime of x, negative sine. H triple prime of x is negative cosine. And if you differentiate 4 times, you come back to sine of x. And then you see that it's going to repeat again, right? Well, I guess we needed to explicitly compute up till here, so why not just differentiate one more time to find out the answer for the fifth derivative? That's okay. Now, what will be the 101st derivative? To answer this question, think about this. What will be the 100th derivative? Now, you see that every fourth derivative, you come back to sine, right? Because once you're at sine, you're rebooting the sequence, right? So it's recurring, right? So every fourth, the next time you get the sine will be what? H differentiated how many times? 8 times. Right? And then it's going to go 12, 16, and so on and so on. So at 100th derivative, what are you going to get? You're going to get sine again, right? So what are you going to get at the 101st derivative? So in case when the answer to the question itself is hard, then try to ask the next next hardest question. So this is slightly easier to answer than this one. So that's the idea.